In this video, we will review and calculate CMOS inverter delay. As you recall from the first lecture, propagation delay is defined for two cases. Propagation delay high to low is the time starting from the input is switched from 0 to 1 until the output reaches 50% voltage transition point. Second case gives propagation delay low to high, which is the delay between the input switching from logic 1 to logic 0 and output is switching from 0 to 1. Propagation delay is the average of TPHL and TPLH. Other two delay definitions are rise time and fall time. Fall time is the time that passes between 90% and 10% of this falling edge, and rise time is rising edge equivalent. To calculate delay, we need to estimate the average capacitance during the transitions. Then, delay term can be found by load capacitance times charge in voltage divided by the average current through the lumped load capacitance during the transition. For TPHL, voltage changes from VOH to V50%, and for TPLH, voltage changes from VOL to V50%. The change in current is more complicated because it changes as the output voltage VDS voltage changes. We can approximate the average current by averaging the current over two operating points shown here. The current charging or discharging the capacitance IC is the difference between the drain current of PMOS and drain current of NMOS. For the falling output, the load capacitor is discharged through NMOS. So, when we do the derivations, the resulting expression is a function of Kn and Vt of NMOS. On the other hand, PMOS charges the load capacitance during a transition from low to high. So, TPLH depends on Kp and Vtp. From these equations, we understand that for a faster inverter, we need bigger Ks or bigger W, meaning wider transistors. However, we also want to keep the total capacitance minimum. This capacitance is sum of extrinsic capacitances and transistor parasitics called intrinsic capacitances. Transistor parasitics are proportional to V times L dimensions of the transistor.